Okay. Anybody can confirm? Are you able to see the screen? Okay. Yes. As I mentioned, we're discussing about in our first class. Better to keep everybody muted. So that if you have any doubt, you can raise your hand in chat box so that I'll unmute you. Yeah. As I'm explaining you, for example, if your work area, which is about 100 SFT. So here 15 SFT, you should be keep it as your openings, or it is for the ventilation purpose. So the 15 SFT may be in the form of windows, in the form of doors, or in the form of secondary set of windows. Okay, that is the one of the requirements. Now, inlet opening should not be obstructed by the surrounding buildings. This is also one of the key aspect we have to consider whenever you are doing or whenever you are giving any specific openings. It should not be obstructed by this is surrounding buildings, then any walls or any portions which are there, or any trees or any other obstructions in the air path. So these are all things we have to consider wherever you are giving an inlet opening for your building. A great advantage is available by the providing windows in the west and east directions. However, if the wind direction is not effectively available, the opening in the all four can be helpful in the form of natural ventilation. So always we look for this ventilation in west and east directions. The windows will help us for getting good natural ventilation. If you are not able to find out, or it is difficult to get the in west and east, so you can provide all four sides of openings so that you will get a good ventilation. I will see some of the proofs and also some of the ventilation systems which is suitable for which kind of atmosphere. You see here the span of this building. When assume it is in the building, the span of the building is 20 meters. Here with a flat roof, a cross ventilation is effective when a span is less than 20 meters. Cross ventilation in the sense, maybe if you assume this east and other side is the west, so where you are giving the openings, so that what will happen, this is an east side. Okay, sorry. It's an east side, it is in a west side, so that whenever the air passes this way, or if the ventilation is in this way, there you'll get a cross ventilation. It is suitable for only a 20-meter width or the span of the building. If your span is more than that, so in that case, what will happen? This ventilation is not going to help. If it is above 20 meters. When the room temperature is higher than the outside because of hot processes or seasons, etc., the cool outside air tends to enter through the openings at the low level, and also the warm air tends to leave through the openings at the high levels. So as I mentioned you in the beginning of the class, so whenever the temperature difference in the room and the outside atmosphere, what will happen? It will always tends to the cool air enters from the lower level and the warm air leaves through the openings at the high level. Therefore, there would be an advantageous to provide ventilation near to the ceilings. That's where we used to provide the ventilation at the ceiling level, so that whenever the internal heat or the air which is get heated up, then automatically it will go out from those ventilation openings, so that we'll get a good comfort. Now, roof ventilation, a cross ventilation suitable for the narrow buildings is not much suitable for the large buildings, and where the roof ventilation is suitable. The roof ventilation is suitable for the large buildings. If a small workshop, it is a cross ventilation is well suitable. If it is in a big industrial building, there they go for a roof ventilation. And here the ventilations are provided in the roofs, crawl, vent pipe, or curved roofs, or rigid vent pipes, or stacker vents. We'll see what are the different types of roof ventilation. If you see here, these are the common industrial buildings. It is in called as pitched roof. Here you will have an opening. So here you have an opening, an opposite side also an opening. Then same opening, whatever the hot air which will go up, or maybe from this way also it may come down, or in this way it will go up. In other way, it is in a reflected or a monitor roof, or a repetitive monitor roof. And this is a sawtooth roof. So these are the different types of the building, the roof structures. Okay. Now we'll see what kind of ventilation system can be suitable for this kind of buildings. Now we'll see a modified pitched roof and a monitor roof. We have seen a monitor roof and a pitched roof. If you see a modified pitched roof, how the air flow here, the air will go this way, then it will escape from here, or some of the air may come this way, and it will come here, or some portion of air it will go this way, so that wherever there is an availability, the air will go here. If the air will go this way, in the sense the occupants are in this area, it will passes through occupants, then it will take the hot air into outside, then the fresh air will comes up. If you are keeping any obstruction near the entry of the air, you will not get any proper ventilation. You should not keep, or you should not allow anything to be obstructed for the air inway or air inlet. Then this is the sawtooth roof ventilation. As we see, this is the sawtooth roof. In the sawtooth roof, see through what will happen here, you will have an openings. See the arrow marks which is projecting out. There is a top outlets. So this is the main inlet. The air will go this way, as well as the hot air will go in the outer side or the top side of the building. Then if it's a modified monitor or modified repetitive monitor, it is called as modified or monitor roof or modified monitor roof. So here also same phenomena. You will have one roof, it will go away. If it is in a combination, it is in multiple these things, what will happen? This air can go this way, and also it can escape from here, or in the real linear manner also, the air can enter and it will cool the atmosphere which is inside the building. These are the various ways we can provide ventilation for industrial buildings. This is for modified, it is a pitched roof, and other one is for a modified sawtooth roof, and again this is for the modified monitor roof. Okay, these are the different types of ventilation systems for the various kinds of roofs. Now we'll see a mechanical ventilation. The mechanical ventilation is employed for buildings, that is for workroom, also for the process for removal of contaminants. So when it will be used, it is it is for the workroom and also removal of contaminants. Then if you see the building ventilation, there are many types of classified areas. It is a natural ventilation is not sufficient to keep the thermal environment within the limits specified by the dry bulb or wet bulb. in the factory's rules. So, and also the span of the room which is exceeding 18 meters, or where any workplace is more than 9 meters away from the ventilation opening, a mechanical ventilation shall be provided in the case of any positive ventilation, or air shall be cleaned and also cooled before sending into the workroom. So here what will happen, whenever the room size exceeds 18 meters, and also a workplace which is away from 9 meters from the ventilation opening. So where there we have to install this mechanical ventilation system. What we'll do, one is exhaust or negative ventilation system. Here what we do is, an exhauster include a draft fan are provided in walls on one side of the building or in the attic or a roof to draw a large volume of air through the building. Here you have to observe to draw a large amount of air, from the building. These fans are generally a propeller type. So what will happen here? They will take out the air from the inside the building. And the windows and other openings near the fans should be kept closed to avoid the short circulating of the air. How it will get short circulated? For example, this is my building. This is properly. Yeah, this is my building. Then here I've put my exhaust fan. And here there is a window. You should not open this window at all. It should be closed, because here the air will go out, from here it will come in. So there is no proper effect on this portion. So wherever there is a close by the windows and doors, it should not be open, or it should be in a closed position. So whenever you are putting this mechanical ventilation system, what will happen? So it will be taking out of the complete air. So if you assume this is a ventilation fan, so it will be drawing out the air from the complete building. So that what will happen, if you have any openings in this side, it is going to be useful, because whenever this fan starts working, it is taking the air from the complete building. Automatically this fresh air starts coming inside. So that what will happen, this area, the temperature will come down, and even the contaminants also get diluted. Even the dust particles also will be removed. And also in case of any odor or smell issues in the workplace also get be removed. Even the humans, they'll feel comfortable because of the temperature is maintainable or manageable condition. That's why if you're putting in a fan which is outside, the opposite side, you should have an opening so that the fresh air will come inside. Okay. Then adequate inlet opening shall be provided on opposite side of the building to limit the inlet velocities. That is already we have discussed. You can see the exhaust fan should have the windshields on outside of the wall, and also the wind pressure may not be decrease the efficiency, and the fan discharges should be diverted into the large ducts carried out vertically upward with a rainwater cap at the top, and the fan should have a proper guarding and fencing. So once it is exhausted, maybe if you are close to any building is there we can't leave directly. So this exhaust fan is connected to a chimney or a duct with a rainwater cap to avoid the water getting inside. So this exhaust air will go out. So as I mentioned, you see here, there is an inlet of this air, and here I have an exhaust fan. So that what will happen, the air which comes in, then it will go this way. So that automatically this complete portion, it will get cooled. That is the advantage of this mechanical ventilation, wherever you are not able to get natural ventilation sufficient or which is not meeting your requirement. Now, local exhaust ventilation. It is applied to the release points of the contaminants. As I mentioned, it is exactly on the point of operation to reduce their concentration in the workroom or TLV, threshold limit values. And but in the case of the exhaust appliances shall confine the contaminants as much as possible. So what will happen? It is necessary for the process, but in the case the exhaust appliances shall confine the contaminants. And the volume of air is required is calculated from the area of the openings and also the capture velocity and sufficient to prevent the outward escapement. And also the size of the duct shall be calculated from the volume of air required. And also the duct velocity is necessary to convey the contaminants with a minimum static resistance. So whenever you are designing this exhaust systems, you should calculate the volume of air or the volume of the exhaust size to suck from the specific respective location. Yes, as I mentioned, this is in a process area where the emissions or contaminants are generating. The hood is directly on above the work area so that it will suck the air, then it is connected to the dust collectors. Okay. With this, we have done this topic. If you have any questions, you can discuss. Oh, I'm sorry. I have to unmute your people. Thank you, Praveen. What about others? Okay. Thank you then. See you in the next class.